Brake shoes might look like unremarkable crescent-shaped pieces of metal, but the reality behind their production is more intriguing and more controversial than many people realize. From the dark origins of asbestos-laden linings to the whispers of toxic adhesives in modern factories, the story of how brake shoes are made may just change the way you think about your next ride. Keep watching, because what you're about to learn could shake up everything you know about motorcycle safety. Motorcycle brake shoes didn't always command the level of engineering we see today. In the early 20th century, riders rarely hit the same speeds we do now, so the braking systems were simpler, almost quaint by current standards. But as motorcycles started gaining power and pushing boundaries, the need for reliable, high-performing brakes soared. By the 1930s, it was obvious that stronger materials and more complex designs were necessary to keep riders safe, and from there, the evolution of brake shoes kicked into high gear. One of the earliest controversies surrounding brake shoes was the use of asbestos in the friction lining. Back then, it was prized for its resistance to heat and wear. But some experts were quick to sound the alarm, pointing to health hazards factory workers faced when inhaling those fibers. Nobody wanted to believe that these so-called miracle linings could endanger employees or riders. Yet rumors about workers getting sick prompted a wave of investigations, eventually leading to serious restrictions and huge changes in how friction materials were made. Though it's easy to assume we've come a long way, some countries only recently phased out asbestos completely. This lag has sparked endless debate over which factories might still be using outdated materials. Regardless, the quest to keep riders safe continues to fuel new solutions and spark new controversies behind the scenes. At the core of a brake shoe is a simple-looking metal frame, sometimes called a web or backing plate. This backing is what you see when you remove your motorcycle's wheel and open up the drum brake assembly. It might not look special, but every curve and thickness has a purpose. It must withstand intense friction, vibrations, and sudden changes in temperature without warping or cracking. If it fails, the results can be catastrophic. So how is this essential piece made? The raw metal, often steel or a special alloy, arrives in sheets or strips. Manufacturers then stamp or forge these into a crescent shape with remarkable precision. In many state-of-the-art plants, automated presses punch out hundreds of plates per hour, each identical to the last. But rumors persist about less reputable factories skimping on quality, using recycled metals that may contain hidden flaws. Whispers of sudden brake shoe failures on the road fuel speculation that certain companies cut corners on raw materials. Are these suspicions exaggerated to discredit competitors, or are they grounded in truth? Officially, no one has confirmed a definitive scandal, but the mere possibility looms large for motorcyclists who bet their lives on sturdy brakes. After shaping the backing plates, workers or robots drill holes for rivets or bonding processes. Some manufacturers use proprietary patterns or special finishing techniques, secret formulas, they claim, that reduce noise or improve braking performance. This hush-hush approach only increases the mystique surrounding how different brands manufacture their brake shoes. All the while, insiders whisper that these secrets sometimes involve questionable shortcuts, feeding the ongoing debates in enthusiast forums around the globe. Once you have the metal backing, it's time to add the friction lining, the real heart of the brake shoe. In the past, asbestos reigned supreme for its outstanding resistance to heat and friction, despite warnings from scientists and health activists. Over time, public outcry against asbestos reached a boiling point, resulting in phased bans across multiple industries. Motorcycle brake shoe manufacturers scrambled to find new materials that could handle punishing friction without jeopardizing safety or performance. Enter ceramic fibers, metallic shards, synthetic resins, and more exotic compounds that no one outside the factory walls fully understands. Companies often treat their friction material recipes like top-secret intel. A pinch of aramid fibers might be added for high-temperature resilience, or certain metallic powders to reduce noise and improve wear. Nobody likes the idea of brake dust flinging off and floating into the air, so producers often brag about eco-friendly or low-dust mixtures. However, rumors occasionally surface claiming that some overseas suppliers still blend unsafe substances into their compounds, bypassing stricter regulations. These allegations rarely get publicly confirmed, but the uncertainty keeps many riders guessing whether they're breathing toxic particles every time they brake. Manufacturers subject their friction linings to intense lab tests, heating them to extreme temperatures and measuring the effect on friction, wear, and overall integrity. Some claim they run more rigorous tests than their competitors, touting it as proof of superior quality. Others are accused of faking data to secure certification. In the fiercely competitive brake market, these swirling rumors and controversies only amplify the secretive aura surrounding friction linings. Once a factory has both the metal backing plate and friction lining ready, the next step is attaching them, either via mechanical rivets or with adhesive bonding. Depending on who you ask, this is where some of the greatest controversies arise. Riveting is straightforward. Small metal rivets are inserted through the lining and into the metal plate to anchor them together. But over time, rivet holes can cause cracks or weakening in certain friction materials, especially if the process isn't done correctly. Adhesive bonding, on the other hand, demands careful handling of industrial-strength glues. A thin layer is spread onto the metal, after which the friction lining is pressed into place. When executed perfectly, the bond can be just as strong or stronger than rivets. But if the factory environment isn't strictly controlled, toxic fumes can leak out, harming workers. Reports claim some adhesives might still be based on chemicals that pose serious health risks, though official confirmations are scarce. That vacuum of information fuels anxieties that shady factories could be endangering their staff and unwitting customers alike. Additionally, speculation abounds that adhesives sometimes fail under extreme heat or sudden temperature changes. Imagine riding downhill, braking continuously, and your brake shoes simply peeling apart from the backing plate. While catastrophic failures are rare, the fear of a lurking adhesive flaw is enough to keep certain riders awake at night, especially if they frequently push their bikes to the limit. Even after the lining is attached, the brake shoe isn't quite ready. Usually, the newly bonded or riveted shoes are placed in finishing machines where excess material gets ground away to create perfectly matched arcs. This ensures the shoe fits snugly within the drum brake. Workers often wear protective gear to avoid inhaling the fine dust that flies off during the grinding process. Ironically, it's this dust that once made asbestos-laden brake linings so notorious, because asbestos particles could linger in the air for hours, potentially entering workers' lungs. But that's not the only hazard. Modern friction materials often contain synthetic fibers and metal filings that may still cause respiratory or skin irritation. No one wants to think that brake manufacturers are producing toxic dust, yet controversies occasionally spike when rumors circulate about poorly ventilated plants. Factories that boast high-end extraction systems and employee safeguards gain bragging rights, assuring the public that their product is manufactured responsibly. After grinding, the brake shoe might be tested in a specialized rig to confirm its curvature is correct. Minuscule differences can cause uneven contact with the drum, resulting in squeaking, rattling, or even reduced braking power. In a best-case scenario, these flawed shoes are discarded before leaving the factory floor. But the rumor mill has churned out stories of unscrupulous operations selling factory seconds on the cheap, sometimes rebranding them as new, top-grade components. This unscrupulous practice, if true, could undermine the trust riders place in their brakes every day. Quality control is generally the final checkpoint before brake shoes go out the door. But is it always as thorough as manufacturers claim? Ideally, each batch is randomly tested for thickness, bonding strength, and real-world performance simulation. Some companies use dynamometers that spin the brake assembly at various speeds, applying pressure to replicate intense braking conditions. Others even boast about elaborate road tests featuring professional riders pushing the limits to ensure no hidden defects lurk within the friction material. But there are whispers that smaller factories might skip the more expensive steps. In an industry where profit margins can be razor-thin, a few unscrupulous players might decide rigorous tests are just too costly. A quick inspection for cracks and a quick spin on a smaller rig might be all that's done before shipping. If any major problems do occur, the hope is they get caught during distribution or by unsuspecting riders who notice an issue. While no one wants to believe it, The possibility that some factories compromise on safety to save money remains a persistent cloud over the market. Part of the confusion comes from the fact that each country can set its own testing and certification standards. A brand that passes one region's rigorous tests might rely on self-certification in another. Riders then have to decide which regulatory seal truly guarantees safety. Rival companies sometimes accuse each other of faking test results or bribing inspectors. In such a competitive environment, discerning fact from rumor can be a challenge, even for experienced industry insiders. Once those brake shoes leave the factory, the real test begins on the open road. Casual commuters typically place moderate demands on their brakes, while track racers and off-road adventurers might push them to extremes. Overheating or fading can happen if the brakes are engaged for too long under high speed or steep downhill conditions. Supposedly, some manufacturers design their brake shoes to wear out faster, hinting at the controversial concept of planned obsolescence. The idea is that shorter lifespans force consumers to buy replacements more often, lining the pockets of certain large-scale producers. Conspiracy theories abound. Enthusiasts share anecdotes on message boards about specific brands that seem to degrade suspiciously fast. Others speak of material contamination that leads to squealing or inconsistent grip after only a few thousand miles. Officially, these remain unproven. But the sheer volume of stories keeps the rumor mill alive, with riders wondering if there's a kernel of truth buried beneath the hype. Some notable controversies have made headlines. One major recall in recent years involved a globally recognized brand that discovered its brake shoes were cracking under repeated high-speed stops. The resulting scandal caused massive financial damage and a huge shakeup in the industry. Skeptics claimed there was more to the story. Whispers of sabotage, defective adhesives, or corporate espionage floated around. The manufacturer itself blamed a production glitch at a third-party supplier, but conspiracy lovers and tabloids thrived on the drama. Regardless of the real cause, the fiasco highlighted just how reliant we are on these small, unassuming components to keep us safe. So after hearing all these twists, turns, and controversies, where do we go from here? In response to health and environmental concerns, some manufacturers have shifted toward eco-friendly materials, organic fibers, or blends free from heavy metals. Enthusiasts argue about whether these green brake shoes hold up as well under extreme conditions. Some claim they overheat more easily, while others say the difference is negligible compared to older generations of friction compounds. A handful of companies are experimenting with ceramic or carbon-based brake linings that promise smoother performance and minimal dust. Certain high-end racing brakes already incorporate advanced composites, hinting at a future where the notion of old-school metal and fiber brake shoes might become obsolete. Yet cost remains a major barrier. For daily riders on a budget, these high-tech materials can seem out of reach, keeping conventional shoes in steady demand for the foreseeable future. Even the shape and design of brake shoes could evolve. In certain corners of the motorcycle world, you'll hear about radical new concepts that integrate cooling fins, advanced vents, or built-in sensors to measure wear in real time. Though these are mostly prototypes or limited-run parts, they showcase the potential for dramatic improvements in safety and performance. Engineers argue that data from sensors could warn riders before a catastrophic failure, or alert them to replace shoes before they become dangerously thin. Naturally, each new development brings its own controversies. Skeptics question whether these innovations really address safety, or if they're just marketing stunts designed to command higher prices. Others worry that more complex designs might introduce more points of failure. The conversation is ongoing, fueled by riders, mechanics, scientists, and conspiracy theorists alike, all with their own opinions on what the future of braking should be. Motorcycle brake shoes are often taken for granted, just another item you replace when you service your bike. But beneath that ordinary exterior lies a realm of engineering marvels, secret formulas, brand rivalries, and sometimes downright alarming practices. We've journeyed through the murky history of asbestos, the hush-hush friction compounds, the adhesives that hold everything together, and the possible corner cutting that might lurk in dimly lit factories. And we've seen how cutting-edge technologies promise a new generation of brake shoes that might push safety and performance to unprecedented heights. Yet even the best innovations can't fully erase doubts. riders still whisper stories of suspiciously fast wear, brand feuds, and unconfirmed allegations that some components on the market might not be as safe as they should be. Each time we hit the brakes, we trust that piece of curved metal and friction lining to protect us from whatever lurks on the road ahead. Ultimately, it's a decision each rider makes, to either trust the brand they've chosen or to question everything and dig deeper into the unknown truths of brake manufacturing.